Hi, it's been a while since I've done any videos on YouTube, but I've just acquired a pair of Quad 2 power amplifiers and I thought you might want to go through this journey with me. I've rebuilt a couple of quad preamps in the last few months, so I thought it was about time that I rebuilt a quad power amp to go with them. Yeah, some time back I bought the metalwork from China to build one of these Quad 405 clones, and I'm quite impressed with the quality of it. So I thought it'd be nice to have the preamp and the tuner that sort of goes with it. So I got both of those items off of eBay, both faulty. They're both fixed, they're both cosmetically quite good, so that's a complete little system there, and it sounds fantastic, absolutely brilliant. The Quad 405 has got a massive toroidal transformer in it and plus other mods, so it sounds pretty good. So with a view to the future, once I'd repaired this and upgraded it, I added this pot here so that I can vary the output from 500 millivolts, which is the correct voltage to drive a 405, up to 1.4 volts RMS, which is the correct voltage to drive a pair of Quad 2s. The beauty of the 34 and the 44 is that they're very easy to configure to give virtually any output you might want. To be honest, because of the way our hearing works and the way music goes up and down, I don't think most people would notice the difference between whether it's a half a volt or a full volt output from this preamp. But the thing is, if I'm going to run a pair of Quad 2s from it, they're only rated at 15 watts per channel or so, so I want to give them a fighting chance of giving their maximum output. I've retained the original Jones connectors and mains connectors, but obviously you only need these when you're using this preamp to run a pair of Quad 2s. Most people would run Quad 2s with a more modern preamp, I think, these days. So let's make some room and get these on the bench. So here they are in what I would call average condition for their age. They all seem to suffer from these outbreaks of rust, but that's only to be expected after 60 odd years, I suppose. The EF86s, that's these, are a mixture of Mullard and Pinnacle. Looks like it's probably got the original Mullard GZ32 rectifiers in there. All four of the output valves are 6N3Cs, which is a sort of Cyrillic numbering system. We know them as a CP3S, which is really an equivalent of a 6L6. I've checked them all in my trusty little valve tester, which I knocked up last year, a U-Tracer 3, which is absolutely brilliant. And all the valves are fine, so no problems there. I've got quite a few of the classic shape KT66s from GEC, Marconi, Osram, a lot of them in original boxes. So my aim is just to show the work really on one of these amplifiers, because hopefully the other one will require the same amount of work. Let's just get this one out of the way and get this into a position. Let's take the valves out and remove the bottom cover. As you can probably see, it's just 4 screws to hold on the bottom cover, so that's pretty easy. So now we can see what we've got. Let's have a closer look. Yeah, some work's been done. There's the Achilles heel there, the 180 ohm bias resistor, which that can be modified. You can put 2 resistors in to bias each valve separately, but I don't know whether to do that or not. We'll cross that bridge when we come to it. Everything else looks quite good. Let's get the other amplifier up and just see if the same work's been done on it. Yeah, so don't know if you can see that. Yeah, the same work's been done. So this is probably, I doubt if it's broken down, it's probably been sent off somewhere for a service, and that's what they've done. My initial thoughts were to replace this little board here with a PCB, and not so sure now. Again, I'll strip it down and we'll see where we are a bit later on. And here we got C4 and C6, which you can just see the connections there, which are both 16 microfarad. And this, because this is a 1950s design, they were pretty big in those days. Nowadays they're a lot smaller, so I may remove this completely and substitute it with two modern equivalents. So let's start the strip down. Not quite sure where to start, but this capacitor seems as good a place as any. I've already loosened these nuts at the top, and also, I don't know if you can see on the side, you have to remove these screws that hold the sort of plaque on the side, because they also hold this main smoothing electrolytic. So that's all the screws out, so this should hopefully come off, but it's been probably stuck on there for years. So that was a bit more difficult than I thought. Okay, and the plate is damaged in the corners like they nearly always are, but I've got a solution to that. I've already had some plates made up, so I'll be able to change these later. It's out now. You can see that there is 16 plus 16 at 450 volts, and I can see it's got this same stuff here on the bottom, and I realise now it's what's oozed out of the transformer over time, and it's snuck into there behind here and then crept out through these holes. And if you want a quick look inside, this is how it looks now. Okay, needs a bit of a clean up around the transformer. So now I'll move this out of the way and do the same to the other one. I've got them both out now, so as a matter of interest, let's measure them, see how they have held up over the last few years. So this is my E terminal from amp number 1. So I'm at 21 microfarad, ESR of 1 ohm. And this is my P terminal from amp number 1. So just under 18 microfarad at 0.31 of an ohm ESR. And here's the E terminal of amp number 2. So 21 microfarad at 0.97 of an ohm. Very similar to the first one. And here's the P terminal of amp number 2. Again, 17.49 microfarad at 0.29 of an ohm ESR. So that's pretty impressive. I never throw away my old components, I always label them according to what I've taken them out of, just in case I ever need to return them back to their original condition. So these are well worth keeping for the future, or if I don't use them, they do sell quite well on eBay. Well, I've got the transformer out and cleaned it up. Doesn't look too bad. Here's the mess that was left behind on the chassis. As you can see, I've started to scrape it off and clean it up a bit. So these transformers are operating right at the edge of their comfort zone, really. And you've got a hot KT66, you've got a rectifier there pumping out the heat, and also one of these transformers will power the preamp and the tuner, so there's quite a load on there. I've seen this before, and it doesn't necessarily mean that the transformer's failed, so I'll just clean it all up, and when I put it back in we'll see what happens, but it should be fine. Luckily it's a cold day today, so most of the pitch just chipped off, and following that I just rubbed it down with some IPA and a bit of Scotch-Brite, and it's nice and smooth now, and also I'm back to the original colour here so that I can get it matched perfectly later on. The next step is to remove as much of the loom as possible. The two output valves sit on this metal plate here, so if I remove that plate then a lot of the wiring should come with it. So this is all loose now. I've removed the choke and cleaned it up, just 2 screws. So I've loosened these 4 screws here. I've disconnected the mains connector, the Jones plug and the 2 speaker connections, and now I've just got to remove the output transformer connections here. So now, yeah, the whole thing comes free. Need to do some more cleaning up here on the transformer and the chassis. It's nice and clean. I'll just clean everything up now before I carry on. So here's all the constituent parts. I'll just remove this little sub chassis now. So this is removed, ready for cleaning up. I'll remove the little circuit board. So before I take it to be sandblasted, let's just have a look at this metalwork. The rust is pretty significant, and there's some holes that I'm going to want to fill or blank off in some way, but we'll come to that a bit later. So while I've got some time to spare, should we just check the value of some of these resistors? I've got a 1 meg here, which is R2. There's nearly 1.4. We've got R3, nearly 1.3. Then I've got a couple of 180Ks. It's 194. Oops. 248, oh that's quite bad. So these are all Erie 5 and 10% tolerance resistors, and if you've worked on old equipment, it's no surprise to you that the high values really do go high over time. So I'll be replacing all the resistors with a sort of modern 2 watt equivalent. The quarter watts look much too small, so I'll stick these sort of 2 watt ones in, and should be okay. You can see again there's a load of that transformer pitch on this board, which I should be able to clear off okay. And here it is, cleaned up with new ceramic valve bases. It's come up really well actually. I've removed all the resistors, so I'll replace those now. And here we are, all done. So that's this board complete now. Here's the 2 boards side by side. I've made a selection of blanking plates so that when the metalwork comes back from sandblasting, I'll be able to fix these plates like so to make a nice smooth surface. Any holes or gaps afterwards I'll fill with car body filler. This is both boards done now, so I can put them to one side. So here's all the metalwork ready for sandblasting. I've covered the tops of the transformers just to keep any sand or debris out of the terminals. I've got the main chassis parts back. I'm just waiting on the transformers now. I've spent a couple of days on these chassis. This is the end with the voltage selector and the fuse holder. So this has been blanked off. I still need to do some more work. This isn't perfectly smooth yet. And at this end I've got the 2 speaker posts and the input. I'll just show you. So hopefully it's going to look something like this when it's finished. I'll get that in there. The speaker post will go something like that, and the inputs will be something like that. So that's the sort of way it should look after it's all painted and finished. I've just got a little more work now just to very finely abrade that so that it's perfectly smooth, and then we're on to the next stage. I've blanked off the holes and filled them with car body filler. Before I take them for painting, I'll just do a quick trial fit. I just want to see if I've made any glaring errors. I don't want to get it painted only to find I've got to drill more holes or blank something off. Main electrolytics was 16 plus 16 microfarad, as you probably know. I decided to upgrade them to 47 microfarad, which won't tax the GZ32 rectifier too much. And so I've got a few here. I've got axial and radial, and the advantage with these small ones, they're so much smaller than the originals, is that you can actually put them where you need them. So you could actually put them in the chassis along there, say, down here, or you could put radial ones sticking up along there. But the only problem was they seem to flap around a bit on the breeze. I can't find a decent way of holding them. I expect they'd probably be alright, but I was thinking about it, and I came across some lovely F&T 50 plus 50 microfarads, which is this one here, really high quality German one, and it's quite small, and I thought, why not just utilise the space where the original smoothers were, so put it there. And then all I need to do is mount it, and the best way to do that is to use a couple of Terry springs or Terry clips. So what I'll do is I'll mount that there, and this will necessitate drilling a couple of holes here, which is underneath the mains transformer, so they won't be seen. So this is the beauty of doing a trial fit, because you find out these little gotchas along the way. By the way, I've removed these old discoloured BA nickel screws from here and retapped them to M4. So these are now got stainless steel M4 cheesehead screws. Here's the transformers and chokes. They've been sandblasted and primered. I just want to rub them down a little bit before I apply the top coat. I'm just fitting new ceramic octal valve bases into this little sub chassis while I'm waiting for the paint to dry. Here we are, all sprayed now in gunmetal. It's taken a couple of weeks to sort this lot out, but it's all looking quite good now. Good enough for me anyway. So I'll start assembly next. The paint's fully hardened off and I've cut it back and polished it, so now I'm ready to start reassembly. Here's all the hardware fitted. Let's just have a look round. You can see the on-off switch at one end, and the speaker posts and phono socket. So here's a closer view. And this is what it looks like underneath. So it's a question of wiring up now. So here's the mains inputs and filament wiring complete. Next thing is to do the HT rail and signal cables. I'm a bit further along now. A fair bit of the wiring's done, and I've got to the point where I need to mount C2 and 3. One of them's in position there. The original design had metal-bodied coupling capacitors, and they were clamped to the chassis using these metal clamps, and that gave a slight capacitance between the body of the capacitor and ground. So I've got a quad here which is modified by Quad themselves using an official mod for when they replace these coupling capacitors. To make up for the lack of capacitance to ground, they've put these little 33 puffs across each EF86 from the anode to ground, and I'll see if I can show you on the circuit. So those 33 puffs, they just go from there to ground. So you're getting that additional bit of capacitance before C2 and C3. As this video is mainly concerned with the rebuild, what I'll do is build it all, try it out, and then take some measurements afterwards, and I may have to adjust the wiring or add additional capacitance to get the frequency response nice and flat. Well, some time's gone by now, but finally finished the wiring and it actually all works, which is quite gratifying. There's just three little points I want to go over. You might notice that I've fitted a tag strip here, and I've got two 360 ohm cathode resistors fitted. This is a modification. The original quad, as you probably know, had a 180 ohm cathode resistor shared by both the KT66s, which was a bit of an Achilles heel. So this is quite a well-known mod in that you put two 360 ohm resistors, one for each of the KT66s, and that improves the performance and also helps with the heat dissipation. The other point is that I've fitted this capacitor here from the input, from the phono input. The reason for that is when these were originally sold, you would have had the quad preamp with it, but now this is operating as a standalone amplifier. You never quite know what's going to be plugged into it, so just to be on the safe side, it's best just to put a capacitor there. The final thing is this 10 ohm resistor here, which just isolates the ground of the circuit from the actual metalwork of the chassis. So one final thing which I'll fit right at the end after I've done the other amp is obviously the badge. Now these get broken quite badly, so I've had some new ones made. So now I just need to do the same to amplifier number 2, and then I'm good to go. Well, another few days have gone by and here's both amps together. I thought I'd try them with the proper GEC KT66s, which do look pretty impressive, I think. Also, I've just finished these speakers. I knocked them up using full range drivers, and they're not too bad actually. They're very efficient, which is what I need for the quad, of course. And I'm running them through this preamp and tuner combination, as you can see. But it all sounds quite good at the moment, but I'll get them in a proper lounge environment later on. Well, at last they're in a domestic environment. That was a bit of Vaughan Williams there. They seem to be equally happy playing Vaughan Williams or Metallica, and I'm quite surprised at the volume that I get from these 15-watt amplifiers. So I thought I might bring some of my other amplifiers down and maybe do a comparison at a later date. So I've got my new speakers here. I've got my old quad monoblocks, Malik monoblocks, and my single-ended triode amplifier, and it's funny because I actually get about 17 watts from the quad 2s. I get about 45-50 watts from the monoblock quad 303s, 12 watts from the Leak TR12s, and just 7 watts from the single-ended triode amp. So it'll be interesting to do a comparison, although it's a lot of faffing around. So I might investigate that for a video later on. So thanks for watching. I'll just play a bit of Metallica now.